Alright, so hey everyone, welcome back to the video, and in this video we are basically going to be talking about how you can create terminal bench tasks and what is the overall architecture, because if you understand how terminal bench actually works rather than just doing TUV run, etc, etc, you'll have a better understanding on how the tasks are created and what to check, what not to check, how you should write your task instructions, how you should write your tests, how you should implement like the whatever idea that you have in your mind, how you can make a good task out of it. All right. So starting with, what exactly is terminal bench? Now terminal bench is ideally called as a test harness. I like to call it the agent multiplayer or whatever environment, because what happens over here is this environment is governed by a Docker container. All right, so this is governed by Docker. Pardon for my handwriting, but yeah. Now inside this Docker container, agent does all of its things, and it's ideal that why we have chosen Docker, because agent we have given full right access to agent. Now inside the container, AI agents such as Claude, GPT, and Gemini, and all these AI agents come here and work in this environment, which is a terminal-based environment. Hence the name T-bench or terminal bench. They don't get a GUI thing because, as you have seen, Claude and other Chat GPT codecs, they basically go there, use terminal-based commands such as cat, sed, sed, cat, echo, and sometimes Python as well, writing scripts to modify the file system to achieve the task, because most of the things that we do on a GUI is available through a terminal-based environment. All right. So this particular thing is governed by your Docker file. All right, and Docker compose and Docker file. So now so the flow starts from here. You set up the environment. You set up some things like what is needed for the task, all the pip requirements, TensorFlow if required, PyTorch if required, and all those things that is required for the task. If there is any library, any command line tool, that's also written inside the Docker container. Now when the as a developer as well, we set up our dev environment. So this is the agent's dev environment governed by Docker. All right. Now after we have reached the stage, now there comes three paths. One is the instructions. I hope it's visible. Yeah. One is the instructions, and then the execution and the testing part. So let me give you a quick example because it's easier to understand these through example. So let's say I have to create a task for an AI agent in which I'm telling the AI agent that you have to create a function which adds two numbers. All right. Now, ideally, what you'll write over here is create a function that adds two numbers. That would be your instructions. All right. Now, these instructions are interpreted by ChatGPT and Claude, and they do their stuff over here. All right. And then we have the run.test.sh files, basically your test harness, and then the testing is done. But there is a fundamental catch over here. If you just write that please add two numbers, there are infinite ways to do that. In Rust, in Python as well, we can have add two numbers, to sum, add two numbers, addition of two numbers, and all these functions. And even on top of that, you have this files as well. Like agent may say that, oh, I'll create in main.py file or add some.py file, some.py file, etc. So as you have not specified that clearly in the instructions, agent will just go here and do whatever it wants, because the instruction has to be vague, but not that vague, because here if you have some sort of way to test whatever is written over here, you test it over here, then it's good. But since it's not available, because in testing you're basically using PyTest, and probably you will just do from some file name import this which is the function, and then you will just assert whether this function is equal to let's say 4 because you have written 2 plus 2. All right, but in this case, maybe this file is not available. You are thinking in your mind that agent would create main.py with a sum function, but this was not clearly specified in the instructions. All right, cool. So we understood this. Why we have to write. Now, what are the ways to do that? So the first way is write all of the things in the instructions itself, right? Let's say be as specific as possible. So create a file named main.py in which there is a function named sum which adds two numbers. Now this is pretty good instruction because we have the file name, we have the function name. Now we can test that over here. The second approach which I like personally is creating a debugging task. The add function is not working, all right? And in the task dependencies, we can have pre-built tasks over here. And in the Docker container, I would add some files like main.py in which we have a bunch of functions. Inside that function, there would be addition of two numbers, and those two numbers would be like I will be doing anything inside that. And I'll tell the agent to fix that based on my requirements. That's one. Another one is if you don't want to create debugging tasks because every time you cannot create a debugging task, then what you can do is you can have this thing called boilerplate, right? So inside this, you'll already, let's say in the Docker container, you already have the main.py file and you have the dev sum file, and you just say here pass. Like this, you can create a boilerplate function, and now you can in the instructions you can tell the agent, I have the file. Can you please implement a function to add two numbers? So now we already have some task dependencies. So agent would just go over here, implement it here, and then we can have the testing phase. All right. Now this is what is the flow. The first one is agent. The harness runs from the Docker container, sets up the environment, goes to the instructions, reads the instructions, do the things, the execution over here, and the testing is done. And based on that, it says whether the agent is passed or not. Now there are multiple concepts which you might be not familiar of. The first one is the Oracle agent. Like, I don't know, GPT you know that it does, but there are two agents as well. I don't know if you, but I'll just cover them as well. Oracle and NoOp. Oracle is basically whatever solution that you have written. Okay, there is a solution.sh file that you have to write, which basically means you have in this whatever solution that you want to write over here. When this functions run, you can have something like cat and replace this file with the actual function, etc., etc. So this test pass. So this is the solution.sh. This is run by the Oracle agent. Oracle agent is nothing but an agent that applies your solution to the Docker container so the test passes. Because because it's your solution, then it has to be correct, so the test passes. Now the NoOp agent, what NoOp agent basically does, it doesn't do anything. That's what the name says, no operation. It installs the dependency, but it doesn't read the instructions, it doesn't go to Docker container, anything, directly jumps to testing. And inside here, this function fails and the NoOp agent fails, because NoOp agent is there if there is no operation happening and still your test case is passing, then basically you have the solution right inside your Docker container. All right, so I hope you got this idea of how this whole thing works. All right, now let's go over some ideas on how you can come up with some new tasks. Okay, so now we'll start with how you can come up with some new tasks over here. All right, so I would say to come up with some new task, you should have because there are a lot of experience that you also might be having, such as in my case there were test harnesses, sometimes the model weight quantization problems, some algorithm problems, sometimes the CSV parsing problems and all those things. Fast API to Django, we have to migrate to different languages, Rust to Golang, Golang to Rust, and all those things. To come up with a good task, I would say that you should go interdisciplinary. What I mean to say is, let's say we are focusing on Python problems, all right? But so we can also have some task in which we have PyO3 bindings, in which we write the bindings inside Rust, and then we call that thing in Python. So we can have some task like improve the throughput of this particular function by writing this particular thing using Rust, using Py3 bindings, and check whether it's working or not. Now, the working or not is defined by the speed of the throughput, and that's our core functionality. Now, now when you're implementing a task, rather than having like a bunch of different test cases, like 53, 54 test cases, 30 test cases, you don't have to do that, all right? There might be some only the core functionality should be to check whether the throughput increased or not, what's the size of the file, uh, whether there are any edge cases or not. So in these cases, these are some like 4 to 5, 6 test cases max, and then we can cover this whole task in the core functionality. Now this defines a good task because it's a realistic problem. Many agents would not be able to do that because you just test, all right? Try using Claude if you can do that, and you know how to implement that correctly, write a solution for it. Only test the core functionality, and inside that I would also specify the method names. Sometimes what happens is, let's say you have LLM dot throughput, and the functionality is correct, but sometimes agent would, if you do not have specified the method name, it would say like increase throughput or something like that. Now this you are checking, but this you are not checking, but both of the functions have the same functionality. So this basically you have to keep in mind that you don't do these kinds of mistake. So now you get a hold of it, how to come up with good task. I would say if you are using LLMs to create task, then at least the task instructions and the test cases should be of your own, all right? And based on that you can modify the solutions and all those things, but these two are the important things because based on the instructions and test case, you are writing the solution.sh and you are creating the task dependencies. So I think in my mental model, if you are coming up with instructions and test cases on your own, like what is the task and what should we actually check, then you can give it to an LLM, and LLM will try to create a good task, and then you can improvise on that based on your software engineering knowledge. Cool. So I think I'm clear on this. Now some tricks that I have been using to come up with some of the tricks that I have been using to come up with the task is number one is obviously, and the most obvious thing is you all are doing some problems. You might have got some errors that you are not able to using ChatGPT. There were multiple iterations between you and ChatGPT, and that is a good task. You can add that over here. All right. Second is, if you are run out of task, then I would suggest go to GitHub issues. Think of some simple repositories. Let's say there was one of the things in Light LLM, and try to replicate those kinds of GitHub issues. So there are like a bunch of repositories and some good projects which are not high level offline projects. Go to them, see the issues, try to replicate a small POC of your own in the task dependencies and the solution, and you have a good task, because if the issue is there, then there is high probability that you might come up with a good task out of that issue. All right. So second is that. Third is, there are some MCP servers such as Context 7. Go to them, ask them about what are some of the GitHub issues. Try to figure that out on how you would be able to solve their solutions. And then when you have solved that, you kind of have a mental model that if I were to have this task on a low scale level, let's say in Light LLM as well, I would not have, for example, in the Light LLM, that's a huge library. But what you can do is, I have that orchestrator problem. I can have like a buggy orchestrator as in the task dependencies, and I would tell them, hey, can you fix this? And then based on that, you have a good task over there, right over there. All right. So these are the three things that I know that you can use to create and come up with some good task. And yeah, I guess that is it. That was the whole thing. If you want me to cover anything else in task creation or what is terminal bench, then I'm happy to do so. Till then, see ya. Have a good day. Thank you.